In this example, we'll add a presenter microphone to an existing project and make some changes to the configuration file to support the new application. In an earlier example, we created a SoundStructure project with 8 table mics, and we'll use this project for this example. As a starting point, we can either work offline, or if we were able to connect to the system we want to work with, we can connect and work online with the system, making changes in real time to that system. For this example, let's start with the project and work offline. First, we open the project and go to the matrix page. To add a presenter microphone, we'll add a lectern mic. To do this, select the Edit Channels button and add a lectern microphone, and then we'll change the name of this microphone to be Podium. With the Edit Channels control open, you can see all the channels that have been defined in the system. It's possible to remove channels or add channels at this point. But remember, you can only add channels up to the number of free channels you have on your device. If you want to add more channels than you have inputs or outputs for, you can use the Edit Devices wizard that's found on the wiring page to change the SoundStructure devices used in the project, including any telco cards in your design. The Edit Channels and Edit Devices wizards work the same way as the initial project creation tools work and are there to make it easy to modify your designs. Adding the Podium mic increases the size of the matrix by 1 input. Because the Podium microphone is a microphone, the system knows to add Podium to the mics group and also to route the audio to the HDX video participants and also to the remote phone participants. By default, this microphone is used just like the other microphones. It's sent to the remote participants but not reinforced into the local room. To enable the reinforcement of this microphone into the local room, there are several changes we must make. First, we need to unmute the Podium microphone to the amplifier. By unmuting, we will have the ungated version of the microphone, or in other words, a version of the signal that does not include the automatic microphone mixer. Recall from an earlier example that the white cross points mean that the ungated version of the signal is used. In other words, the signal is not running through an automatic microphone mixer. We want to use an automix version of the microphone to get the benefits of the automixer, including reduced noise and also reduced room reverberation, because fewer microphones are active when the automixer is enabled. To get this, we must select a gated type. From the Edit Crosspoint control, we see there are 2 gated type options, the conferencing and sound reinforcement gated types. These 2 options differ in the processing paths that the audio channels follow. For the conferencing gated type, the input channel runs through the input equalization, acoustic echo cancellation, noise reduction, nonlinear processing, and then the automatic gain control, dynamics processing, automixer, signal delay, and mute. For the sound reinforcement gating type, the signal also runs through the input equalization, acoustic echo cancellation, noise reduction, but the signal does not run through the nonlinear processing. In addition, the signal processing includes a feedback eliminator. By not running through the nonlinear processing, the signal will not have any suppression applied to it. This means that the local microphone audio will not be suppressed even if the acoustic echo canceller wants to suppress it because of the presence of remote audio or because the acoustic echo canceller is not fully converged. Because of this, the sound reinforcement option is the version of the signal that you want to use for reinforcement into the local room. In addition, the feedback eliminator option provides another 3 to 6 dB of additional protection against in-room feedback if the local presenter gets too close to the loudspeakers or the reinforcement gain is increased too high. After selecting the gating type for this crosspoint, we will also adjust the gain of the crosspoint to lower the signal level that is reinforced into the local room. In this example, I've set the crosspoint to -12. The final value can be adjusted on-site based on the levels required for the local participants to hear the talker at the Podium microphone well. Now, as we learned in a previous example, the echo canceller reference is set to amplifier by default. However, this causes a problem for the Podium microphone because the Podium microphone is played out the amplifier channel 2, which means now that the podium microphone is in its own acoustic echo canceller reference. This will cause the acoustic echo canceller to fight the podium microphone audio and will create a choppy version of the audio that's sent to the far side because both the acoustic echo canceller and the nonlinear processing will try to cancel the podium microphone audio from the signal that's picked up from the podium microphone. To fix this, we need to have a valid echo canceller reference for the podium microphone that does not have the podium microphone in it, but does contain all the remote audio that we do want to cancel. The way to do this is to create a submix that contains all the remote audio and then set that signal as the reference for the podium microphone. To do this, select Edit Channels and select a new submix. Because we have stereo audio coming in from the HDX and are using a stereo amplifier, let's select a stereo submix. Let's change the name on the submix to be Remote Audio and then press Add. Once you close the Edit Channels window, you can see that this submix signal has been added to the matrix. Submixes are colored differently from the input and output signals and have a purple color. You can see that the remote audio submix is stereo by looking at the graphic symbol below the name. The submix signal is both an output from the matrix and an input back to the matrix, as you can see by scrolling down on the matrix page. To properly use this submix, let's unmute the same audio in the submix that's going to the amplifier, with the exception of the podium microphone. We can do this quickly by right-clicking on the cross points to toggle their mute state. Next, let's unmute the audio from the submix to the amplifier channel. Now we have two versions of the remote audio being sent to the amplifier. Because submixes add 1.5 milliseconds of latency to the signal, we do not want to have two versions of the signal going to the amplifier with different delays. So let's mute the direct feed from the remote audio sources to the amplifier by right-clicking on those cross points. Now, all the remote audio is sent out to the submix, and then the submix is routed back to the amplifier channel and summed with the podium microphone audio signal. If you collapse the mics groups now, you'll see that the group crosspoint for the mics to the amplifier now has a boundary that indicates that at least one crosspoint value for the members of the group is different from the other members. This is caused because our podium microphone is reinforced into the room. Now that we have the submix added and the proper signals routed to the submix and the submix used properly, let's go to the channels page and expand the AEC control. For the podium microphone, we will change the echo canceller reference to select the remote audio submix. With this change, the echo canceller reference for the podium microphone includes all the remote audio. The echo canceller reference for the table microphones can be left as the amplifier channel. This way, when the podium microphone is active and coming out of the loudspeakers in the room, the echo canceller for the local table microphones will cancel any of the podium audio that might be picked up by the table microphones from the local loudspeakers. This will minimize any alternate path that the podium microphone may take as it's sent to the remote side, resulting in the highest quality presentation audio that can be heard at the remote site. If the echo canceller reference for the table microphones was changed to be the remote audio submix, then when the podium microphone is reinforced into the room, that audio will be treated as a local talker, and if it's loud enough to activate other microphones in the room, then those microphones will transmit that audio to the remote side as well. These multiple copies of the podium microphone audio will cause the podium microphone to sound more reverberant to the remote participants than if we left the AEC reference for the table microphones to be the amplifier channel.